Hello everyone, welcome back again to another video. You are watching Math with Teacher Riva. You would be spending another 1 hour for today learning new topics. Again, this is Math with Teacher Riva. Are you ready to begin? Alright, if that is so, then let's start. And let's start with a short recap of what we studied last time. Last meeting, we learned about equiangular quadrilaterals, squares, and rectangles. Again, equiangular quadrilaterals, squares, and rectangles. What are these things? What are these objects and shapes? Pictures of these shapes will be flashed on your screen now. Let's read. These quadrilaterals are called equiangular quadrilaterals for they have 4 angles. These 4 figures on the screen are called equiangular quadrilaterals. Why? Because they do have 4 angles, just like this one. Let's count. 1, 2, 3, 4. 1, 2, 3, 4. Basically, shapes that have 4 angles, you can call it equiangular quadrilaterals. Examples. You can see a lot of examples of equiangular quadrilaterals in real life. Example number 1. What is this? Good job! It is a book. And a book is an example of an equiangular quadrilateral. What else? You saw it right. It's a banknote. Banknote. Banknote is another example of an equiangular quadrilateral. Another one. Very familiar to you, right? This is an example of an equiangular quadrilateral. A ruler. Ruler. These are just some few of the examples of an equiangular quadrilateral objects. Book, banknote, and a ruler. Can you still find more of these objects? Same as these objects? Well, you try to identify. There are a lot more. Let's try. What is this? Alright, it is a fan. It is a fan. Is a fan equiangular or not? Very good. It is not an equiangular quadrilateral. It is not an equiangular quadrilateral. Great job, everyone! How about the next object? a cabinet? Is a cabinet an equiangular quadrilateral? Alright, very good. It is an equiangular quadrilateral. How about a box of a gift? Box. Is it an equiangular quadrilateral? Okay, very good. Yes, it is an equiangular quadrilateral. How about this figure? Is this figure an equiangular quadrilateral? Yes or no? Alright, it is not an equiangular quadrilateral. From the figure itself, it is a triangle. It's not a quadrilateral. Can you follow? Just simply remember, equiangular quadrilaterals are shapes having 4 equal angles. Remember? Equiangular quadrilaterals with all sides that are equal are what we call squares. Again, equiangular quadrilaterals with all sides that are equal are what we call squares. Can you repeat after me? Squares. Okay, good job. This is how a square looks like. If you can see, a square really has 4 equal sides. 1, 2, 3, 4. Okay, they have 4 equal sides. Good job. How about the next one? Everybody read, please. Equiangular quadrilaterals with long and short sides are what we call rectangle. Rectangle. Okay, this is how a rectangle looks like. Indeed, a rectangle has a long side and a short side, therefore giving us a knot. Alright, giving us a knot equal sides. Everybody say again, rectangle. One more time, please. Rectangle. Let's try to see if you can identify and differentiate between squares and rectangles. This time, I will be showing you pictures. Try to identify it by yourself whether it is a square or it is a rectangle. We have here our first 2 pictures. Our first 2 pictures are a clock and a pillow. Clock and pillow. Let's have the clock first. Is the clock a square or a rectangle? Is it a square or a rectangle? Very good! It is a square with 4 equal sides. Great job! How about the pillow? Is the pillow a square or a rectangle? Is it a square or a rectangle? Alright, very good. It is a square again. The pillow is a square. The pillow is a square. Doing good, everyone. Let's go to the next pictures. The first picture over here, we have a box of a toothpaste. Again, a box of a toothpaste. Is it a square or a rectangle? Is it a square or a rectangle? Awesome! It is a rectangle. You got it right. A box of toothpaste is rectangle. A box of toothpaste is a rectangle. How about the briefcase? Is it a square or a rectangle? You got it right again. It's a rectangle. A briefcase is a rectangle. A briefcase is a rectangle. Alright, we're down to the last 2 pictures for this topic. How about this Rubik's Cube? Is it a square or a rectangle? Is it a square or a rectangle? Very good. It is a square. Again, one more time, please. It is a square. Now, how about the envelope? Is the envelope a square or a rectangle? Is it a square or a rectangle? Okay, very good. This envelope is a rectangle. Good job, everybody. You identified and differentiated square from rectangle. 2 thumbs up for you. Alright, we are now done with the square and rectangle. But wait, there's more. Do you know that when we do have square and rectangle, it forms the what we say diagonals. Can you repeat after me? Say diagonals. One more time. Diagonals. Very good. Let's try to look at the square. A square has 2 diagonals. And when they meet, they form an intersection point. Let's name each of the endpoints. A, B, C, and D. We have 4 points this time. A, B, C, D. Let's try to identify the name of the quadrilateral. The name of this quadrilateral is quadrilateral A, B, C, and D because These letters are the points of each end in the diagonal. And the names of our diagonals, which we have two diagonals, it's line AC and line BD. Again, there are two diagonals in a quadrilateral square, and the names of these diagonals are line AC and line BD. Same goes with a rectangle. A rectangle also has two diagonals that meet each other. Let's name it W, X, Z, and Y. The name of this quadrilateral is quadrilateral WXYZ, since it's the points of each diagonal line. Moreover, the diagonal names are line WY and line XZ. Follow? Again, it's line WY and line XZ. These are the diagonals for quadrilateral WXYZ. Okay, so much for quadrilaterals and lines. This time, let's move on to another familiar object or another familiar shape. What picture is this? Okay, good job. It is a clock. How about this one? What is this? Very good. It is a donut. It is a donut. How about this one? Very good. It is a ball. It is a ball. What is this? Alright, it is a pizza. It is a pizza. What is this? Very good. It is a cookie. It is a cookie. Now, what is something in common with all of these 5 figures? What is something common with these 5 figures? The clock, the donut, the cookie, the pizza, and the ball. What thing is the same with all of them? Alright. The thing that is the same to all of these objects is that they're all in what shape? Okay, very good. They're all in a circle shape. Now everybody say circles. Circles. C-I-R-C-L-E-S. Circles. Okay, very good. Now, let's try to know the different components of a circle. Components of a circle. Number 1. If you try to see a circle, the circle has a point over here, and let's name it point A. The point here is what we call center. Center. Everybody, repeat after me, please. Center. Okay, center is the point that is the same distance from any and all points of a circle. So from here or here, here or here, here or over here, the measurement or the distance of it are still the same. Again, what is this? Center. Good job. And the entire circle, we can call it as circumference. Again, please. Circumference. When we try to get the circumference of a circle, we multiply the radius by 2 and its pi value. You will know it later on. Okay? Again, center, circumference. Okay, let's move to the next one. Another component of a circle is from line CD or line DC. This component is called diameter. Diameter. The diameter is the line that connects 2 points of a circle and it passes through the center. So when you make a line, if it passes through the center and it connects the 2 points here or here, then it's called diameter. Diameter. Alright, it's the third component already. Now, let's move to the fourth component. The fourth component of a circle is when the center and another point meets each other. This is what we call radius. Radius. Alright, the radius is the line that connects the center of the circle to a point of a circle. Example, this point A going to point Y. It's the radius. Alright, we had circumference, center, diameter, and radius. Let's try to see if you can remember. Let's identify which of the two figures shown is a correct figure of a component of a circle. Let's start with the center. Which of the two figures is the correct figure for a center? Is it figure 1 or figure 2? Okay, the center is the first figure. Again, because the center has to be put in the center, not on the other points of the circle. It must be over here, where point K is. Next, After center, let's move on to the radius. Let's move on to the radius. Which figure is correct? Is it figure 1 or figure 2? Okay, the radius is figure 1. Good job. The correct figure of a radius is figure 1. It has to be connecting the center and another point in the circle. Radius. How about identifying the correct figure for circumference? Is it figure 1 or figure 2? Okay, very simple, right? The circumference or the correct circumference of this figure is figure 2. Good job. Figure 2. Why? Because figure 1 is not a circle. Circumference is for circles, not for ovals. Alright? Next one. Let's have the correct figure for diameter. Which of the two figures is the correct figure for a diameter? Is it figure 1 or figure 2? Okay, of course, it's figure 1. Great job. Why is it figure 1 and not figure 2? Because the line here connects to another point in the circle and passes through the center. This figure does not pass or did not pass through the center. That is why this is not called a diameter. So, can you follow? Can you just follow? Have you understood it? Okay. Now, let's have vocabulary check. Alright. Repeat after me. Okay? I will say the word first and you say it after. Alright, let's have the first word. Listen, say diagonals. Diagonals. Your turn. Good job. Second word. Listen, everybody. Say circles. Circles. Your turn. Well done. Third word. We have circumference. Circumference. Your turn. Okay, very good. Fourth word. Center. Center. Your turn. Alright, doing good, everyone. Let's have the last two words. Listen, everybody. Say diameter. Diameter. Your turn. Good job. And the last word we have here, Radius. Radius. Your turn. Good job, everyone. Well done for this day. I think that would be all for today. Thank you all for listening and watching. See you next time here in Math with Teacher Riva. Keep safe always. Goodbye, everyone.